Hello everyone. In this video, we will study about the irrigation canal design theories, that is silt theories. Now, in your syllabus, there are two theories. First is Kennedy's theory and second is Lacey's theory. Okay. Now, types of channels. We have already studied the different types of dams and all. So here in this chapter we will start from the types of channels. Okay. This is the general statement that the hydraulic design of a channel or a irrigation canal is governed by mainly two factors. Okay, which are those factors? First is the quantity of silt in that water which is carried by that channel or the canal. Silt means the small particles of soil, or you have already understood what is meant by silt in the geotechnical engineering subject. So the quantity of a silt which is carried by the canal is the first factor which we have to remember while designing or while do the hydraulic design of a channel. And the second factor is the type of boundary surface of that channel. ओके, फर्स्ट क्या होता है कि कोई भी रिवर है और कोई भी रिजर्वायर है और उस रिजर्वायर से हम लोग कोई भी कैनाल डाइवर्ट कर रहे हैं इरिगेशन पर्पस के लिए, तो क्या होगा कि वो जो रिजर्वायर है उस रिजर्वायर में से सम अमाउंट में जो सिल्ट होगी, सिल्ट पार्टिकल्स होंगे, वो सिल्ट पार्टिकल्स क्या करेंगे, कैनाल में आ जाएंगे. ओके, तो उन सिल्ट पार्टिकल्स की क्वांटिटी कितनी है, जो वाटर कैरी कर रहे हैं वो सिल्ट पार्टिकल्स की क्वांटिटी कितनी है, वो भी डिपेंड करता है हाइड्रोलिक डिजाइन को. ओके, और सेकंड पार्ट क्या है कि वो जो कैनाल हम लोग डिजाइन करने वाले हैं और वो जो कैनाल डिजाइन हो चुका है पहले से, तो उसका बाउंड्री सरफेस क्या है. आइदर वो लाइन कैनाल है और वो अनलाइन कैनाल है, और अगर वो अनलाइन कैनाल हुआ तो जिस जमीन पे वो एक्सकवेट किया है वो सॉइल का टाइप क्या है. ओके, अगर वो एल्यूवियल सॉइल है और या नॉन एल्यूवियल सॉइल है, रॉकी है, etc. Okay, now based on these we may have three types of channels. Okay, or a canal you may say. The three types of canal we have: first is alluvial channels, second is non-alluvial channels, third is rigid boundary channels or a line channels. By the name, you can easily understand the third type of channel, that is a line channel. Okay, first is, we will go one by one. First is the alluvial channel. Now, alluvial channels are those which are excavated in alluvial soil. Now, alluvial soil is that nothing but the soil which contains silts, lot of silts. Okay. Now, अगर वो सिल्ट में एक्सकेवेट किया हुआ है, सिल्टी सॉइल में एक्सकेवेट किया हुआ है, तो ऑब्वियसली क्या होगा कि उसके अलोंग जो वाटर आएगा वो वाटर अपने साथ लॉट्स ऑफ सिल्ट लेके आएगा. ओके, नाउ as it carries lots of silt, what happened? The boundary or a weighted perimeter of that channel, which weighted perimeter of that channel will therefore get eroded. Okay, how erode that? How to erode that? It will soar the entire perimeter of that channel. Okay, now such channels are called as a alluvium. Okay, ऐसे जो चैनल्स होते हैं उनको क्या कहते हैं, एल्यूवियम कहते हैं. ओके, जो चैनल्स एल्यूवियल सॉइल में एक्सकवेट किए होते हैं, सॉइल्स सच एज अ सिल्ट, तो दैट चैनल्स आर कॉल्ड एज अ एल्यूवियम. ओके, अभी ऑब्वियसली क्या होगा कि ऐसे वाटर में, ऐसे चैनल में जो वाटर फ्लो हो रहा है उस वाटर में क्या होगा कि सिल्ट कंटेंट वेरी लार्ज होगा. ओके, इट कंटेन्स अ लॉट ऑफ सिल्ट्स अलोंग इट्स लेंथ. ओके, तो पहले जैसे मैंने एक्सप्लेन किया, अगर उस वाटर की जो वेलोसिटी है वो वेलोसिटी अगर हम लोग इंक्रीज करते हैं, ओके, अगर वेलोसिटी इंक्रीज हुई तो क्या होगा कि पूरे चैनल का जो बेड होगा, पेरीमीटर होगा और बेड होगा, सरफेस होगा, जो भी वेटेड सरफेस होगा, वो वेटेड सरफेस क्या होगा, इरोड हो गया, दैट मीन्स सोर होगा, ओके, बेड भी होगा और उसकी साइड्स भी क्या होंगे, सोर होंगे, क्योंकि उसमें सिल्ट कंटेंट ज्यादा है। सिल्ट कंटेंट ज्यादा है तो फ्रिक्शन होगा उसके बेड पे और उसके साइड्स में, तो जो भी उसके वेटेड पेरीमीटर के अलोंग जो भी साइड्स और बेड आएंगे वो क्या होंगे, सोर होंगे, ओके। तो सिल्ट कंटेंट अगर ज्यादा हुआ तो वेलोसिटी भी ज्यादा होगी, ओके, दैट मीन्स वाइस वर्सा, वेलोसिटी ज्यादा है तो सिल्ट कंटेंट क्या होगी, उसकी ज्यादा होगी। अगर हम लोग वेलोसिटी कम करते हैं तो क्या होगा, ऑब्वियसली सिल्ट कंटेंट क्या होगा, डिक्रीज होगा, ओके। और अगर सिल्ट कंटेंट वेलोसिटी हम लोग डिक्रीज करते हैं तो ऑब्वियसली क्या होगा, ये सिल्टी सॉइल है, ओके, सिल्टी सॉइल है तो वाटर में सिल्ट तो आएगा ही, तो क्या होगा, दैट सिल्ट विल डिपॉजिट, okay, that means the silting of silting takes place, settlement of that silt takes place to the bottom of a channel, okay. So to design or while design of such channels, the designer should aim that such channel should be designed for the non silting, non soaring velocity, okay. For a given discharge, designer should design such channels for a non-silting, non-soaring velocities, okay. Now this is about the alluvial channels. Now the non-alluvial channels, I hope you understand the alluvial channels. Alluvial channels are those which are excavated in a alluvial soils, okay. Now non-alluvial soils, non-alluvial channels, similarly as that of the alluvial channels, the non-alluvial channels are those which are excavated in non-alluvial soils, such as a loam, clay, hard soil or a rock, ओके। नाउ नॉन एल्यूवियल सॉइल जो है उसमें लोम, क्ले, हार्ड सॉइल और रॉक आता है, तो ऑब्वियसली क्या होगा कि इसमें सिल्ट कंटेंट थोड़ा कम होगा एल्यूवियल चैनल्स के हिसाब से, यहाँ पे सिल्ट कंटेंट क्या होगा, थोड़ा सा कम होगा, ठीक है। तो इसमें क्या होगा कि सिल्टिंग का प्रॉब्लम नहीं आएगा, दैट मीन्स द सेटलमेंट ऑफ सिल्ट विल नॉट टेक्स प्लेस इन अ लार्ज क्वांटिटी, ओके, as this water is flowing with a non-silting velocity, okay, that means a higher velocity. Now if suppose this water is flowing with a higher velocity, then as this is a non-alluvial channel, the designer should not take any fear for a soaring of sides or a bed of channels, okay. ये नॉन एल्यूवियल चैनल है तो क्या होगा, इसमें सिल्ट कंटेंट कम होगा, ओके। सिल्ट कंटेंट एज कंपेयर टू एल्यूवियल चैनल्स यहाँ पे बहुत ही कम होगा, तो एक तो है कि सिल्टिंग नहीं होगा, दैट मीन्स सेटलमेंट ऑफ अ सिल्ट नहीं होगा, ठीक है, क्योंकि हायर वेलोसिटी से वाटर फ्लो होगा यहाँ पे, ठीक है, और हायर वेलोसिटी से फ्लो हुआ भी तो क्या होगा, सोरिंग साइड्स का जो सोरिंग है वो नहीं होगा, ठीक है, क्योंकि सिल्ट कंटेंट ही इसमें कम है, तो साइड्स और बेड्स इसके इरोड नहीं होंगे, ठीक है। नाउ सेकेंड इज द रिजिड बाउंड्री चैनल्स, rigid boundary channels. This name of the channel indicates that this channel is a lined channel, ओके, दैट मीन्स इस जो भी इसके साइड्स और बॉटम है, ये बॉटम्स और साइड्स हम लोग क्या किए हैं, रिजिड मटेरियल से लाइन किए हुए हैं, ओके। तो जो भी लाइन कैनाल्स है और लाइन चैनल्स है वो सब चैनल्स इस कैटेगरी में फॉल होते हैं, दैट मीन्स दी all the line canals fall under the rigid boundary canals, okay. Now in this whole chapter uh, we will design the alluvial and non-alluvial channels, okay. As I have explained you that you have two methods for this study. That first is Kennedy's theorem and second is your Lacey's theorem. Okay, these two are actually the engineers who investigates lots of sites and then proposed some theories. So these theories named after that particular scientist, that is Kennedy's or Lacey's. Now first, how to design the alluvial channels, general information about it. Now first, मैंने जैसे एक्सप्लेन किया है आपको, चैनल और कैनाल जो है वो कैनाल जब हम लोग किसी भी रिवर से या भी किसी भी रिजर्वायर से क्या करेंगे, डाइवर्ट करेंगे फर्स्ट ऑफ ऑल। ओके, एक रिजर्वायर है, रिजर्वायर से एक कैनाल हम लोग क्या कर रहे हैं, डाइवर्ट कर रहे हैं। तो क्या होगा, दैट कैनाल विल टेक्स प्लेस सम अमाउंट ऑफ द सिल्ट अलोंग विथ इट्स वाटर। ओके, so this silt either which carried by suspension और क्या होगा, उसका सेटलमेंट होगा। ओके, आइदर क्या होगा, वो जो सिल्ट है वो सस्पेंशन में फ्लो होगा अलोंग द कैनाल वाटर, और क्या होगा कि बेड जो है कैनाल का, उस बेड पे वो सेटल हो जाएगा। ठीक है, अभी सस्पेंशन में फ्लो हो रहा है तो भी प्रॉब्लम है और सेटल हो गया तो भी प्रॉब्लम है। क्यों प्रॉब्लम है, अगर सिल्ट लोड जो है, जो वाटर कैरी कर रहा है वो बहुत ज़्यादा है, तो क्या होगा, एल्यूवियल सॉइल के हिसाब से अगर वो ज़्यादा है तो क्या होगा, उसका वेलोसिटी कम होगा। ठीक है, अगर वेलोसिटी कम हो जाएगी तो डिस्चार्ज भी कम हो जाएगा। जिस डिज़ाइन डिस्चार्ज के लिए वो चैनल डिज़ाइन किया हुआ है, वो डिज़ाइन डिस्चार्ज उसमें नहीं मिलेगा। ठीक है, डिज़ाइन डिस्चार्ज से कम डिस्चार्ज मिलेगा, और ऑब्वियसली क्या हो जाएगा कि वो जो चैनल है और वो जो कैनाल है वो बहुत कम एरिया इरिगेट करेगा, क्योंकि डिस्चार्ज ही कम हुआ है। ठीक है, डिस्चार्ज कम होने के हिसाब से वो एरिया क्या करेगा, कम इरिगेट करेगा। ठीक है, और सेकेंड प्रॉब्लम क्या है कि इट विल इरोड द होल सरफेस ऑफ दैट कैनल। ओके, इट विल इरोड होल वेटेड पेरीमीटर ऑफ दैट कैनल। Okay, it will lose its velocity and it will lose its irrigable area. Okay, so alluvial channels डिजाइन करने के लिए बहुत ज़्यादा फैक्टर्स आप लोग को माइंड में रखने पड़ेंगे। फर्स्ट चीज, वो जो वाटर है वो वाटर सिल्ट कंटेंट ज़्यादा कैरी करेगा। ओके, नाउ अगर वेलोसिटी कम भी किए, क्योंकि सिल्ट कंटेंट ज़्यादा है, तो सपोज कि वेलोसिटी कम की तो भी क्या होगा कि सिल्ट डिपॉजिट हो जाएगा बेड पे। ठीक है, जो कैनाल है वो कैनाल के बेड पे सिल्ट डिपॉजिट हो जाएगा। नाउ एज द सिल्ट इज डिपॉजिटेड एट द बेड ऑफ द कैनाल, व्हाट हैपेंड, actually the velocity is decreases. Okay, as we decreases the velocity, finally the what happened, discharge will decrease. Okay, and again the irrigable area of that particular canal will decrease. Okay, so we have to remember some points while designing any of the canal system, that is alluvial canal system or a non-alluvial canal system. Okay, now uh, now here कैनेडीज ने एक रिलेशन डिराइव किया है। वो रिलेशन क्या है, यू कैन सी हियर, द रिलेशन इज V naught equals to 0.55 d raised to 0.64. Okay, this is the equation for a critical velocity. Okay, critical velocity as non-silting non-soaring velocity। अभी non-silting non-soaring velocity के लिए हम लोग को क्या करना है, वो whole channel डिजाइन करना है। Okay, so this relation is between the critical velocity to the depth of a flowing water. Okay, this relation is for the critical velocity to the depth of that flowing water. Okay, so V naught is obviously your critical velocity and D is your depth of water or depth of water over the bed portion of the channel. Okay, now Kennedys जो है उनको later on ये रियलाइज हुआ कि क्रिटिकल वेलोसिटी जो है, क्रिटिकल वेलोसिटी रेशो जो है, क्रिटिकल वेलोसिटी रेशो वो उन्होंने फिर से इंट्रोड्यूस किया. ओके, दैट क्रिटिकल वेलोसिटी रेशो इज नोन एज m. ओके, एंड द इक्वेशन फॉर दैट इज टेकन एज 0.55 m d raised to 0.64. From this you can find out the m value as critical velocity of the area and divided by critical velocity of upper Bari Dope canal system. Now before this I will explain you the history of this. Firstly, जो Kennedys and Lacy's है, I have already explained that these are the engineers for the irrigation department. Now हम लोग को क्या होता है कि प्रॉब्लम कहाँ पे आता है कि एरिया ऑफ क्रॉस सेक्शन है, हाइड्रोलिक मीन डेप्थ है एंड वेलोसिटी ऑफ फ्लो है. ये जो फैक्टर्स है, ये फैक्टर्स हम लोग को क्या करने पड़ेंगे, हर एक कैनाल सिस्टम के लिए अलग अलग से डिजाइन करने पड़ेंगे. ओके, नाउ दीज आर दी अननोन्स फॉर अस. Okay, and the bed slope, these are the unknowns for us. Okay, now we have two equations along with us. First is the continuity equation and any of the flow equation. Continuity equation is q equals to area into velocity, and the flow equation, this flow equation can be Kutter's equation or the Manning's equation. Okay, this flow equation V equals to can be a Manning's equation or a Kutter's equation. You have already learned about the Manning's equation and Kutter's equation in applied hydraulics for the open channel flow. Now these subjects are, you can see that these subjects are very much interrelated because the canal is a open channel system. Okay, canal is a open channel system. So for finding a velocity, here we are using the Manning's equation or Kutter's equation for the velocity. Okay, I hope you remember the velocity equation for Kutter's and Manning's. Okay, from Manning's and Kutter's you can find out the Chase's equation, Chase's constant. And by finding out the Chase's constant, we can find out the velocity by using V equals to C root mi. Okay, V equals to C root mi, where m is nothing but your hydraulic radius or a hydraulic mean depth. Okay, here in this book you can see that the hydraulic mean depth is denoted by r. So C root V equals to C root r. I can be the equation for your velocity of flow. Okay, just a second. I'll go to Kennedy's theory. Okay, now as I have explained, Kennedy is the one of the engineer. He was one of the engineer. They selected number of sites on the upper Bari Dope canal system. This canal system is one of the oldest canal system in Punjab. Now they investigate this whole canal system for velocity and depth of channel. Okay. Now the problem is that the site which is selected by him did not require any silt clearance for many than 30 years. Okay. That means silt जो थी उसका उसके क्लियरेंस के लिए मोर देन 30 years सिल्ट क्लियरेंस नहीं लगता था. ओके. एंड वहाँ पे अजम्पशन क्या था कि जो भी वाटर फ्लो हो रहा है वो वाटर नॉन सिल्टिंग नॉन सोरिंग वेलोसिटी के लिए फ्लो हो रहा है. ओके. नॉन सिल्टिंग नॉन सोरिंग वेलोसिटी के लिए फ्लो हो रहा है. नाउ व्हाट इज मीन बाय नॉन सिल्टिंग नॉन सोरिंग वेलोसिटी? नॉन सिल्टिंग नॉन सोरिंग वेलोसिटी मतलब a velocity which will just keep the silt in suspension. okay. जिस वेलोसिटी में सिल्ट पार्टिकल्स जो है वो सस्पेंशन में रहेंगे विदाउट एनी सोरिंग ऑफ चैनल, दैट वेलोसिटी इज कॉल्ड एज योर नॉन सोरिंग नॉन सिल्टिंग वेलोसिटी. That means the silting will not happen as it is non-silting and soaring will not happen as it is non-soaring. Okay. So we will move further directly for the design procedure for the Kennedy's theory. Okay. The design procedure for the Kennedy's theory is here. We can design the section by using two cases. First is from your normal L section and second is from the wood stable. Okay, I will explain what is wood stable. Now first design procedure. This is the very simple procedure. Only the thing is that you have to remember the formulas. 2 or 3 formulas are there. You have to remember that Kennedy's formula, Kutter's formula and all. Okay. First case is from the L section. Okay. This from L section. Here in this case you will give by discharge N, M and S. Now here what is N, what is M and what is S? Here N is nothing but your Kutter's coefficient. Okay. S is your slope. Q is your discharge and M is nothing but your hydraulic mean depth. Okay, hydraulic mean depth. Now in this procedure, first you have to assume this is the trial and error procedure. Okay, you have to try for some depths and if it is correct then you have to stop, or it is incorrect then you have to again take some other try. Firstly you have to assume a trial value of D in meters. Here क्या करना है आपको कि फर्स्टली जो डेप्थ है जो भी वो डेप्थ मीटर्स में कोई तो एक वैल्यू आपको अज्यूम करनी है. ओके, दिस इज द फर्स्ट स्टेप ऑफ द प्रोसीजर. सेकेंड स्टेप इज you have to calculate the velocity v naught from the equation of Kennedy's. Okay, now what is the Kennedy's equation? V naught equals to 0.55 m d raised to 0.64. ओके. नाउ जो भी ट्रायल वैल्यू हम लोग अज्यूम कर रहे हैं वो ट्रायल वैल्यू इस इक्वेशन में आपको सब्स्टिट्यूट करनी है. नाउ by substituting this you will get the value of velocity from the Kennedy's equation. Okay, this is the first value of velocity. Now as they will give us the discharge value. Okay, and right now we have calculated the velocity. by using Kennedy's equation. Now we can use the continuity equation for finding the area. Okay, area of section. So Q equals to AV. Use that equation of continuity and find out the area of cross section A. Okay, here it will be the third step of your procedure. A equals to Q divided by V naught. Okay, now the fourth step is, here up to this you will have the value of D and area. Okay, so by using the geometry of that canal section you can calculate the bed width B. ओके, नाउ यहाँ पे क्या है कि जो भी सेक्शन है वो सेक्शन ट्रैपेजॉइड है ऐसे अज्यूम किया हुआ है कैनेडीज थ्योरम में. ओके, सो ट्रैपेजॉइडल सेक्शन की जो भी ज्योमेट्री होगी वो ज्योमेट्री आपको यूज करनी है और उस ज्योमेट्री से बेड विड्थ यू हैव टू find out. Okay, now here one more assumption is that the side slope of that canal is 1 as to that means half to 1. Okay, half to 1, half horizontal to 1 vertical. Such type of problems you have solved in the trapezoidal section, most economical trapezoidal section. Okay, in the hydraulics subject, so you will be easily understand this. The area for this section can be directly find out by using the formula A equals to BD plus D square by 2. Okay, now up to this you have area also. Okay, so area is the known value, depth is the known value, so by using this equation you can find out the bed width B. ओके, नाउ बेड विड्थ मिल गई है, डेप्थ है हमारे पास, तो वेटेड पेरीमीटर वी कैन फाइंड आउट. ओके, वेटेड पेरीमीटर ऑफ दिस इज P इक्वल्स टू B प्लस D अंडर रूट 5. Okay, so by using this weighted perimeter and the area of cross section you can find out the hydraulic radius or a hydraulic mean depth. Now the formula for hydraulic mean depth is area upon weighted perimeter. Okay, area upon weighted perimeter. So A by P equals to your R or M. Substitute the values or formulas, you will get the value of your hydraulic mean depth. ओके, नाउ हाइड्रोलिक मीन डेप्थ मिल गई है आपको, आपके पास डेप्थ है, बेड विड्थ है, एरिया है, तो कुट्टर्स इक्वेशन यू कैन यूज एंड फाइंड आउट द एक्चुअल मीन वेलोसिटी ऑफ अ फ्लो. सो कुट्टर्स इक्वेशन क्या है, I'll explain that equation. You have to remember all the equations for this. This Kutter equation is from hydraulic subject, so I'll only dictate the equation for this. Equation is C equals to 23 plus 1 by n plus 0.00155 by s divided by 1 plus 23 plus 0.00155 by s in bracket n divided by root r. Okay, this equation is the Kutter's equation. Now from this you have to find out the Chase's constant, and by using Chase's constant you have to find out the velocity. Okay, now after this the very much important step is there. Now we have find out the velocity by using Kutter's equation. Okay, v equals to c root mi. And in previous step, in step 2 we have find out the velocity by using Kennedy's equation. So we have to compare the both equation, both values of velocity. Okay, if this value of v and the Kennedy's value of v are same, then the value of depth which is assumed is correct. Okay, and if not, then we have to repeat the calculation by changing the value of depth. Okay, now 2 to 3 values of depth we have to change. Okay, now this is the first case for the design, which is from L section. Here they will give us the discharge N, M and S. That is discharge, the constant Kutter's or Manning's constant, and the hydraulic mean depth and your slope. Okay, now the second case. Second case is by wood stable. Okay, by using the wood stable. Now here for wood stable they will give us the Q, N, M and B by D ratio. Wood stable is nothing but what is mean by wood stable. Wood stable is the table is one such criteria which was prepared in Punjab. Okay, this is only used by Kennedy's theory. Okay, now as he investigated the canal system in Punjab, so he prepared it, and this is the criteria only. Okay, for the Punjab, and is very much useful for that Punjab area for the design of canals. Okay, now here in this table they have give the b by d ratio, various b by d ratio, and from that ratios they give the slope value, v2 v0 ratio and the minimum velocity for the channel. Okay, now you don't need to take that whole table. In problem you will provided by the b by d ratio only. Okay, the first step is you have to calculate the area in terms of diameter, depth. Okay, area in terms of depth of that section. Here you can see that b by d ratio is given, so we can assume b in terms of d. Okay, so b will equals to d into x. Now as this is a trapezoidal section, you have the area equation as bd plus d square by 2. Okay, bd plus d square by 2. So use this equation and substitute, instead of b substitute dx. Okay, you will get the value of area in terms of depth. Okay, now here in first step we have calculated the value of area in terms of depth of that channel. Okay, this is the first step. Second step is by using Kennedy's equation we have to find out the velocity in terms of depth. Okay, velocity in terms of depth. Now here you can see here that okay, in this uh, in this second equation you can see that by using continuity equation they have find out the velocity in terms of d and the area in terms of d. Okay, now area मिल गया हम लोग को in terms of d and velocity भी है in terms of d. तो discharge by using continuity equation as q equals to area into velocity, we can find out the depth value. Okay, because q is given. Okay, q is given area we have find out in terms of d, velocity find out in terms of d. तो ओनली अननोन क्वांटिटीज क्या रहते हैं यहाँ पे, d is unknown. Okay, d is unknown and the known quantities are q, x and m. Okay, q, x and m. तो जो भी वैल्यू आएगी वो वैल्यू आपकी क्या होगी, डेप्थ की वैल्यू होगी. ओके, डेप्थ की वैल्यू हम लोग को मिल गई. तो डेप्थ की वैल्यू से हम लोग क्या फाइंड आउट कर सकते हैं, बी फाइंड आउट कर सकते हैं, क्योंकि बी बाय डी रेशो जो है वो हम लोग ने एक्स कंसिडर किया हुआ था और बी इन टर्म्स ऑफ डी फाइंड आउट किया था. तो बाय सब्सटीट्यूटिंग द वैल्यू ऑफ डी हियर यू कैन फाइंड आउट द बी, बेड विड्थ. ओके, सो by using this you can find out the hydraulic mean depth, that is r or m, and finally you can calculate the velocity by using Kennedy's equation. Okay, v naught equals to 0.55 m d raised to 0.64. Now this equation can be solved by trial and error, this equation only. Okay, here we don't need to assume the lots of values for x or d, but this equation we have to solve by trial and error basis. Okay, you will easily understand by problems. So we will move further for the numericals. Now the first numerical is, here you can see that in this numerical, design a irrigation channel on Kennedy's theory to carry a discharge of 45 cubic. Take n equals to 0.0225 and m equals to 1.05. The channel has a bed slope of 1 in 5000. Okay, now here you can see that in this problem, now right now I have explained two methods for designing. Okay, first is from the L section and second is from the Woods table. And in this problem they have given the value of q, n, m and s. Okay, b by d ratio is not given, so the problem have to design by using first case. Okay, the case of L section, from the L section. So you have to remember the design procedure for the case 1 and also you have to remember the design procedure for case 2. Okay, now from for this, first the given value is q equals to 45 qmax, n equals to 0.0225, m equals to 1.05 and the s equals to 1 in 5000. Okay, now if you remember, first step for this is you have to assume the trial depth for the canal. Okay, so here they have assumed the trial depth of 2 meters. Okay, here the assumed value of depth is 2 meters. Now the second step is we have to find out the velocity by using the Kennedy's Kennedy's equation. Okay, now the Kennedy's equation is v naught equals to 0.55 m d raised to 0.64. Okay, now here we have already assumed the d value as 2 meters. So substitute this d in the velocity equation and you will get the velocity as 0.9 meters per second. Okay, because m is given, that is 1.05, so only the unknown is d. So firstly we have assumed the trial depth 2 meters and the velocity is find out 0.9 meters per second. Now the third step is we have to find out the area of cross section by using a continuity equation. Continuity equation is Q equals to area into velocity. Velocity here we have already find out, and the Q value is known to us, that is 45 Q max. So substitute it in continuity equation. Area will become discharge upon velocity. Discharge is 45, velocity is 0.9, will equal to 50 meters square. Okay, 50 meters square will be your area. Now as I have already explained, they have considered the sections are trapezoids, and the side slope is half to 1. Okay, so area, the formula for area and formula for perimeter you have to by heart. No need to uh, discover the any other formula. You can by heart it. You will get area equal to BD plus D square by 2, that is 0.5 D square. Okay, here you can see that D value we have assumed as 2, area we have calculated as 50, and the unknown is only bed width, that is B. Okay, so substitute that depth and area, you will get the value of B as 24 meters. 24 meters. So the perimeter is, by using this, the perimeter is, the formula for perimeter is B plus D under root 5. The B value is known, 24. Substitute in the perimeter. You will get 28.47 meters as the perimeter. Now area and perimeter, both the quantities are known. So for hydraulic mean depth, only the condition is area of cross section and the weighted perimeter should be known. So we have calculated the weighted perimeter as 24. Sorry, weighted perimeter is 28.47 and area is 50. So substitute it, you will get 1.756 as the hydraulic mean depth. Okay, hydraulic mean depth. Now from this you have to compute the, अभी एक वेलोसिटी हम लोग ने फाइंड आउट की है जो v is 0.9 meters per second. Now second velocity we have to find out by using Kutter's equation. Okay, now the equation is v equals to c root mi or v equals to c root rs. यहाँ पे r दिया हुआ है, आर हम लोग ने फाइंड आउट किया है 1.75 एंड एस की वैल्यू जो है वो नोन है, दैट इज 1 divided by 500. Okay, now firstly by using Kutter's equation you have to find out the Chassis constant. The formula is 23. The formula is 23 plus 1 by n plus 0.155 by s divided by 1 plus 23 plus 0.155 by s bracket n divided by root r. Okay, so substitute all the values here, that is the value of n, value of s and value of r. You will get the Chassis constant as 49.4. Chassis constant comes out to be 49.4. So substitute this Chassis constant in the equation of velocity by using Kutter's equation. V equals to c root of m I, that is V equals to C of root RS. You will get velocity as 0.926. Okay, now we have to compare these both velocities. Okay, this velocity V and the V naught value. Okay, V naught is 0.9 meters per second and V comes out to be 0.926 meters per second. Okay, now what happened here? What happened here? Here the V naught is much lesser than V. Okay, now in order to increase this V naught, we have to increase the value of D. Now the second trial, this is the first trial, above example is the first trial. So now we have to take the second trial. Okay, in second trial, we'll assume the depth value as 2.2 meters. In first trial we have assumed depth value as 2 meters. So here we will assume the depth value as 2.2 meters. Okay, for the next trial. Now the procedure will be same. First, what happened? The first step we have covered as we have assumed the depth as 2.2 meters. The second step is we have to calculate the velocity by using Kennedy's equation, that is V naught equals to 0.55 m d raised to 0.64. Here m is known. The thing is that only the d will be changing. Okay, here the d instead of 2 we can put 2.2. So the V naught is 0.957 meters per second. Now the area by using the third step is we have to find out the area of cross section by using continuity equation. Now by using continuity equation we can find out the area as q divided by velocity. Okay, here in second step your area comes out to be 47.04 meter square. Okay, 47.04 meter square. Now for step 4, again the trapezoidal section is there having side slopes half to 1. So by using area formula, that is A equals to BD plus 0.5 D square, that is BD plus D square by 2 for trapezoidal section, substitute the value of area, value of depth, and you will get the value of bed width as 20.28 meters. Okay, this is up to the fourth step. This is up to the fourth step. Okay, now we will move further for the next step, that is fifth step. By using this B value, area value, Q value, you will find out the weighted perimeter for this. Okay, you have to remember the formula for weighted perimeter. Perimeter is B plus D root 5. Okay, now B we have find out as 20.28, D we have assumed as 2.2 and root of 5. So P comes out to be 25.2 meters. Okay. Now the R value, which is hydraulic mean depth or hydraulic radius, by using area and perimeter, area is 47.07 and the perimeter we have calculated as 25.2. So the hydraulic mean depth will be area upon your perimeter, which is 1.867. Now the second last step is we have to find out the velocity by using Kutter's equation. Okay, for one velocity we have find out by using Kennedy's equation. Now this is the second velocity which will give the comparison for first velocity and second velocity. Now here we have to find out the velocity by using Kutter's equation. First find out the Chase's constant. Chase's constant is 49.918. This is the formula for Chase's constant by using Kutter's equation. The 49.918 is the Chase's constant. Now put that Chase's constant in the equation. V equals to C root RS. C root RS. You will get the value of velocity as 0.965. Okay, 0.965. Now you can see that the both the velocities are somehow same. Okay, both the velocities are somehow same, that is first is 0.957 and second is 0.965. So the ratio will comes out to be approximate 1. So no need of further trial is necessary. We can conclude that the depth of your flow can be taken as 2.2 meters. Bed width can be 20.28 meters or 20.3. You can approximate it. And the Q, N, M values and bed slope is already known to us. Okay, so here this numerical ends here. We are not going to take the further trial because the ratio for these two velocities, it comes out to be approximate 1. Okay, now like this, you have to design the channels by using Kennedy's theory. This numerical is based on first case, which is from the L section. I'll show you the second example by using the B by D ratio in next video. This chapter is very much easy because only two theories you have to learn. First is your Kennedy's theory and second is your Lacey's theory. Only the thing is that you have to remember the formulas and design steps for this two. Okay, and further the drawbacks for these two theories, that is Kennedy's and Lacey's, you have to learn and you have to compare that which is better. Okay, either Kennedy's theory is better or the Lacey's theory is better for the design of channel. Okay, now we will end here. Up to this you have studied the Kennedy's equation, Kennedy's theory, the design steps for the Kennedy's theory by using for L section also, and for the Woods table or B by D ratio also. Okay, and we have solved one numerical for the design of irrigation channel by using the L section. Okay, so we will end here, and in next video we will move further for the Lacey's theory and some numericals. Thank you.